Welcome to the 5th lesson on concrete design with the RSA software. So far we have modeled the geometry and laws for our structure. This lesson we shall look at some preliminary checks and settings prior to performing analysis, and also the analysis itself. In case you've missed any of the lessons, you can go back to the lesson playlist in the link above. So let's get to it. So we begin by checking out the panel settings. In our case, slab panels are essentially the first elements to receive loads. Therefore, we must decide how these loads are treated and also transferred to the supporting members. So to do that, go to the panel calculation model over here. So the panel calculation model just defines how the panel is to behave as part of the model. This includes how it contributes to the overall integrity of the structure, how it transfers loads, and also whether it should be considered for design. Now, opening its new window, as you can see, we have a couple of presets here. We'll go into new in order to just understand the different parameters within them. So beginning with elastic stiffness, this determines whether we're going to use finite elements or not. Since the RSA software is a finite element design software, if we decide that we don't want any finite elements, the panel that will assign this setting will just become a load transfer member. Simply, there will be no design possible for it. Moving on to rigid connection, this determines whether the panel plays a role in stiffening the structure or making the structure more rigid by resisting rotations and translations on the joint nodes. Then the transfer of loads, this specifies how loads are distributed on the adjoining elements based on finite element or using the trapezoidal or triangular method. So it all depends on what you wish to attain. So in our case, we have different kinds of panels here. We have the floor panels and the staircase panels. So for the floor panels, we can decide, let me just go through a bit there. If we were to decide it to only be load takedown, just double click on it. As you can see, there will be no design. It will only be used for transferring loads. As you can see, two-way. There is no stiffening even provided. If we were to take slab rigid diaphragm, the panel will be taking part in stiffening the structure and also transferring the load. So we're going to create our own. I want to merge load takedown and shell. Before I do that, let me just go through shell. So for shell, we have finite element approved. There is no stiffening. And then transfer of load is analytical, but I'm just going to change it to simplified. So I'm going to take this load takedown two-way. Rather, I've already done it here. So what I've done, I just edited this first one, this load takedown slab, then made it a shell, or allowed it to have finite elements. Then for the rigid connection, there was no stiffening provided by the slab. Then simplified trapezoidal for transfer of loads. So I want to apply it to the floor slabs. So what I do, remember I had created the groups, so this is where it comes in handy also. I just pick on panel, floor slabs. So I've selected all of them. I just click here, it's populated, and then I apply. Then for the staircase slabs, remember it's not really the same way that these staircase are going to transfer loads onto the other members. So I have to be careful in how to consider it. So perhaps I'm going to take if I look at deck slab one way, it's a finite element, that's good, without stiffening for the critical case, okay. Then transfer of loads is simplified one way. I'm going to use this for the staircases. So I go here again, go to panel, group, staircase slabs, then I apply. So that's it on panel settings. So move on to the meshing options. So to access it, just click on this icon. In this case, it might prompt you on whether to first of all select a panel, or rather, if you haven't selected a panel, it will just assume that it's for all the panels. So in the window here, it's best to leave it as default. Of course, you want to automatically select the meshing method for the case where we are not really conversant with these other methods. Then the element size, we want to keep it at 1 meter, which is advisable because the The smaller the size, the more number of finite element members, and that will increase the number of nodes. So it will end up increasing even the time it takes to perform analysis. So it's good to just keep it as default. So press on OK. Then go to these two options here. So the first one, we have local mesh deleting. Then we have local mesh generation. So for deletion, here is the case where we had created a mesh and we want to clear it up. Then for this one, we want to now generate a mesh. So click on it. Then immediately, if you look at the panels, they have some elements created on them. So we have some are rectangular, some are triangular, some of varying shapes. Then one thing you notice is that the number of nodes has increased just to get out to these new additions here. So if you were to delete it, delete the mesh, realize the nodes are 380 for the whole structure. But if you were to just generate, yes, they've gone up to 2,700 over there. So that's it on meshing options. If you wish to view or not view the meshes, you can just click on this icon here. So you can clear it or you can view it. Next up, we look at verification. This is just a check to determine the model's fitness to run calculations. Errors and warnings may be displayed in this case, if there are any. So we're just going to go through some of the errors which may be found and also some remedies for them. To do a verification, go to analysis, then click on verification here. So as you can see, we have an error here or a warning. Computation model is out of date. So the limited verification has been performed. So to cater for that, you go to analysis, then you generate computational model. So allow it to just take its time depending on the size of the project. So once that is done, you can go ahead and perform the verification once more. So as you can see here, the load has not been distributed correctly. There are no object elements carrying the load overlap. That is for the staircase. That might mean that we need to change the calculation model for the staircase. So once you select either of the errors, as you can see here, it will highlight the objects that are affected. So once we've selected them, we just go to the point calculation model, perhaps change it. You can pick, let's pick shell, apply, and close. Then we'll have to now generate for these panels which we have selected. The next step, we want to verify it once more. So as you can see, it's telling us computation model out of date. So we perform it again. So if we were to verify it, as you can see, now there are no errors or warnings. So we'll just go through other errors which may be found. The first one, we have no supports. So in the case where there are no supports, we just select the error that shows us no supports, and then it will indicate to us the nodes that require support conditions defined. Then we have another error, which is isolated nodes. This is when a node is left hanging in space or no element is attached to it. So in the same case, you're going to select the error, it will select the node. So you can either delete it, or you can go to this window and just segregate it or seclude it so that you can perform further investigation. Then you also have separate structure. This is when discontinuity is detected on the structure that you have modeled. Perhaps the software may read it as two structures or two or more structures which are being defined. So this all depends on the kind of project you're running. So it might be an error or not. There are more errors which may be found, but these are just a few common errors which we have tackled. As you can see, we now have no errors in our structure. So we move on to performing the analysis. This is now just the calculations for analysis. By default, analysis type is going to be linear static. This assumes linear properties of the materials and the geometry of the structural members. It's not a very accurate depiction of how a structure is. So we shall consider nonlinear analysis, which accounts for the imperfections or consistencies within a structure. So go to the analysis menu, click on analysis types. So in this window, we're just going to pick out. Of course, analysis will be done for all the different load cases and combinations. So you just want to filter out some of them. So to do that, I'm going to click on these three dotted lines here. I'm going to pick out all the load cases, select them. Rather, let me just select the first one and then shift and close. So once I've selected all of them, I want to change the analysis type. So when I pick on auxiliary, this excludes the members from having results. This is useful especially when you're not interested in the results of certain loads or combinations. So I'm going to keep them as auxiliary. Okay, so as you can see here. Then for these ones at the bottom, these are the ones which I'm very much concerned about. So I'm going to select them individually. Then apply P delta or geometric nonlinearity. In this case, considers the imperfections within the structural model. So analysis is done iteratively, taking account of these imperfections. For the P delta analysis, it considers the changes in the geometry of the structure caused by the applied loads. So it gives the most accurate results, which is a close depiction of the behavior of the structure. So it's a very good way of performing analysis. So press OK. Also do the same for this one, double click on it, P delta, then OK. Then you can close it, or you can just run calculations directly from here. So you can either click on this or you can click on this option here. So calculations, just give it time. So depending on the size of the structure, it's going to take a bit of time. This is the P data analysis that is being performed. So as it's done, you can close it. So as you can check down here, the results are available. So in the next lesson, we'll be looking at now how to just view the different results for the structural analysis. If you found this video useful, you can like and subscribe to the channel so as not to miss the next lesson. See you in the next video.